So next here some note is there. Yeah, you have to keep remembering, this is important thing. The corresponding to each eigenvalue lambda, corresponding eigenvectors is not unique. Just look at here guys, so many questions and so many students are getting confused about this point. The corresponding to each eigenvalue lambda, the corresponding eigenvector is not unique. So it means what? If your eigenvalue is a lambda 1, then for this lambda 1 not only one eigenvector is not satisfied. It means so it is not a unique. You will get more than one, or you will get different eigenvectors for different eigenvalues. Got it? That is such that infinitely many eigenvectors corresponding to each eigenvalue of lambda. So this is what I said here. So for a single eigenvalue you will get infinitely many eigenvector corresponding to each eigenvalue lambda. Okay, so next move on to next point. The set of all eigenvector along with the zero vector forms a vector space, which is known as what? Eigenspace. The set of all eigenvector along with the zero vector forms a vector space. Okay, so this is just a definition of this eigenspace. For diagonal matrix or upper triangular matrix or lower triangular matrix, eigenvalues are the principal diagonal elements. So this is also most important guys. So why? Because so if in your question if they gave you a diagonal matrix or a upper triangular matrix or a lower triangular matrix, then without solving the matrix, it means without solving these questions, so by easily if you just look at the principal diagonal elements, and those principal diagonal elements gives you a eigenvalues. Okay, so this is also most important point. So just look at here. So this is my matrix A. Okay, so this is my matrix A, which is equal to what? So this is a diagonal matrix. So what is the diagonal matrix? Means in a diagonal matrix the only diagonal elements are present. Okay, so these all are what? So this is my diagonal elements. So here only diagonal elements are present. Except this diagonal elements, all elements are what? So all elements are equal to 0. If in your matrix only diagonal elements are present, and accept this diagonal elements, if here all elements are 0, then that matrix is called as a what? Diagonal matrix. Okay, so in your question if you get like this example and if they ask for finding eigenvalues, then by easily you can say that here so a1, a2, 2 and so on up to an are the eigenvalues. Okay, if you want I'll give you example here. So I'm going to take P here. So this is my matrix P, and this is this visible? Okay, so 2 0 0, I'm going to write a 3 cross 3 matrix, 0 and 0 0 6. So this is what? 3 cross 3 matrix. Okay, so what are the eigenvalues of this P? So eigenvalues of this matrix P are nothing but 2, 3, 6. Without solving this question, I said this thing. So how I said means I remember that point. So what that point? So that is nothing but if the given matrix is a diagonal matrix, then eigenvalues are nothing but what? Principal diagonal elements. Got it? Okay, they are solving here. Okay, so they are solving. So this is not so they are solving, and it means this is the proof for this one. Okay, so just look at here. Yes guys, so determinant of it means if you don't know then how this point get created means, so just look at here. So this is what? This is your given matrix. How to find the eigenvalues? First we have to write the characteristic of this matrix, right? So this is what, this is the characteristic equation. So after getting characteristic equation, what you have to do, so you have to take the determinant. Okay, so just look at here. So here I write the a11 minus lambda as here 0 because my all elements are 0 here. So this is what, so now I have to take the determinant of this matrix and I have to write this is equal to 0. So here if I take for finding the determinant, I am going to take first row, a11 minus lambda. Okay, a11 minus lambda. So you have to remove this one and this one, and now you have to find this one. So here except these all, only you have what, so diagonal elements are present here. So at that time, so just look at here, the product of those all diagonal elements is equal to what, 0. Okay, so these all are 0, then lambda is equal to a11, a22, a. So how you will get this thing means these all are what, products. So a11 minus lambda is equal to 0. It means you will get lambda is equal to a11. a22 minus lambda is equal to 0. Then lambda is equal to what, a22. So on up to AAN minus lambda is equal to 0 means lambda is equal to AAN, and these all lambdas are what, so these all are nothing but eigen values. Okay, so therefore lambda is equal to a11, a22, so on up to AN. Okay, so this is the example which is there in my book. So 1, 2, 3. So this is what, so this is given, this is my given matrix. So this is a diagonal matrix. So therefore here 1, 2, 3, these are what, so these are all the eigen values. Let us move on to next. So it is what, yeah, this is the example for upper triangular. Just look at here guys. So this is what, this is my upper triangular matrix. So why, what is that upper triangular matrix? So just look at here. So this is what, 1, 2, 3. Okay, so this is what, 1, 2, 3, 0, 2, 6, 9 and 0, 0, 8. So this is what, this is the upper triangular. So upper triangular means what? So the only where upper, so if you just so this is what, principal diagonal elements. So above the principal diagonal elements, if your elements are present, then you can say that upper triangular matrix, and the below are all are 0. Okay, so just keep remembering like this. Okay, here upper elements are present, so this is the upper triangular matrix. So the given matrix is upper triangular, then of course what are the eigenvalues of this? 1, 6, 8. So 1, 6, 8, these are the eigen values. Okay, so this is the example for lower triangular. 1, 4, 8, these all are what? So these all are in a principal diagonal elements. So here elements are present in a below the diagonal elements. Okay, so therefore this is the lower triangular matrix. Therefore here 1, 4, 8, these are the principal diagonal elements, and so here 1, 4, 8, these are the what? So these all are the eigen values. And another point is there here, just look at here guys, never apply the row or column operation in the finding the eigen values. So just look at here guys, you for finding the eigen values you should not apply the row as well as column operation. Okay, so this is what, this is my notes which we studied now. So now let us solve the given example by using the help of board. So this is my 5th example. Okay, so just look at here guys. So if I give a name for this as a, and this, what is the order of this one? This is a 4 cross 4 matrix. Now we have to find the eigen values of this 4 cross 4 matrix. But we usually find the eigen values by helping of characteristic equation, and after we will solve that lambda value, and we will say that lambda value is the eigen values. But if you observe this matrix, so this matrix is what? So this is which matrix? So this is your upper triangular matrix. Yes or no? Yes, of course. So I already told you in the notes, if the given matrix is upper triangular or lower triangular or diagonal matrix, and what are the eigen values? So eigen values are nothing but what? Diagonal. So these all are what? So these all are principal diagonal elements. So these all are what? So these all are the eigen values. Therefore eigen values of A are, so what are those? First one is lambda 1 is equal to 1 and lambda 2 is equal to 5 and lambda 3 is equal to 1 and lambda 4 is equal to 1. Okay, so please keep remembering this thing. Okay, so because it saves our time in our examination. Okay, so next let us move on to sixth question. So this is what I'm going to take here. 1 1 1, it means this is what, this is a 3 cross 3 matrix. Okay, this is what, this is a 3 cross 3 matrix. So how to find the eigenvalues of this 3 cross 3 matrix? Means here also first we have to take the A minus lambda I is equal to 0. We have to solve the characteristic equation and later we have to solve the roots of this lambda. Okay, so for this also I have a trick, guys. So I'll give you that formula. Please keep remembering that thing. Okay, so if your given matrix A, okay, if your given matrix A contains all elements as the same, okay, then what you have to write means, so this is 3 cross 3. It means how many eigenvalues are present here? Totally 3. Totally how many? 3. Okay, is this visible to you all? Okay, yeah, it is visible. So here what you have to do means, just first eigenvalue is 0, second eigenvalue is also 0 and third eigenvalue you will get the order of this one, so which is nothing but what? 3. So this is what, this is the trick. Okay, so if you want I will solve for taking a 2 cross 2 matrix. Okay, this is what, this is my 2 cross 2 matrix and what is my A minus lambda I here, which is a 0. It means what I will get? 1 minus lambda and this is 1 and this is 1, this is 1 minus lambda, so which is what? 0. So 1 minus 1, 1 minus 1, which is what? 1 minus lambda square minus of 1 gives me 0. A minus B whole square means what? A square plus B square minus 2A B minus 1 is there here. Okay, so 1 and minus 1 will get cancelled and lambda square minus 2 lambda, which is what? Which gives you 0. Just to take the lambda common and lambda minus 2, which gives you what? 0. It means what? Lambda is 0 and lambda minus 2 gives you 0. Lambda minus 2, lambda is equal to 0 or lambda minus 2 is equal to 0. So which I have written here. Okay, so this is one eigenvalue and another eigenvalue is what? Lambda is equal to 2. So this is the first eigenvalue, this is your second eigenvalue. You can observe this one here. Just look at here. So this is what? This is your 2 cross 2 matrix, right? So first eigenvalue is 0 and second eigenvalue is nothing but what? Order of this matrix. Okay, so this trick only I applied here. So even I tried for this thing, it means by checking 3 cross 3, 4 cross 3, so on, then I'll get the same answer. Okay, so just look at here. So I'm going to take another example like 8-1. So here if they give you 1 1, it means so I'm going to write here 7 cross 7 matrix. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. So this is what? 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. 2 3 4 5 6 7. So this is 3 and this is 3, so I have to write another one row. So this is what? This is my 7 cross 7 matrix. Okay, so here also all elements are same. That is nothing but what? 1. Okay, so these are nothing but what? 1 we have here. Okay, so for this also lambda is what? First write all 6 lambda values are 0. 1 2 3 4 5 6 and last eigenvalue is nothing but order of this matrix, that is what, 7. If you want, you can try it, guys. You will get the same answer. Okay. So next point is, a real matrix may have complex eigenvalues. Of course. So real matrix may have a complex eigenvalues. So how I said these things means, so we already solved in examples. Okay, so in example also I check this example, and we will get our eigenvalues in complex form. Okay, so for the example of this statement is what, so here just take 0 1 and -1 0, so this is 2 cross 2 matrix. If you find the eigenvalues of this matrix, you will get your answer as plus or minus I. Okay, so this eigenvalues are what, so these all are imaginary. So imaginary means, so which is nothing but what, so these all are complex eigenvalues. So next come to another point, the complex matrix may have real eigenvalues. So this is also we proved in your example. Okay, so here just take this example, 0i and -i0. If you find the eigenvalues of this complex matrix, you will get your eigenvalues as plus or minus 1. So which are what, purely imaginary, guys. Okay, so we will end this this topic here in this video, and in the next video we will see the properties of skew symmetric and symmetric values, and as well as we will see the properties of transverse and these all things. If you get any doubt regarding this video, please let me know, guys. So if you like the video, give a big thumbs up, and if you are new to my channel, do subscribe. Thank you. Thanks for watching.